1810932006. I will explain the first title about linear regression model. Enjoy!
Let's start our presentation about the simple linear regression model. I will tell you about the definition of the simple linear regression model. Simple linear regression is a statistical method that allows us to summarize and study relationships between two continuous or quantitative variables. As you can see below, y equal b0 plus b1x plus e, where y is the dependent variable, the variable we wish to explain or predict. X is the independent variable, also called the predictor variable. E is the error term, the only random component in the model, and thus the only source of the randomness in Y. B0 is the intercept of the systematic component of the regression relationships. B1 is the slope of the systematic component. The conditional mean of Y, as you can see below, E y per x equal b0 plus b1x. Assumption of the simple linear regression model. The relationship between x and y is a straight line relationship. The value of the independent variable x are assumed fixed or not random. The only randomness in the value of y comes from the error term, where the errors are normally distributed with mean 0 and variance. The errors are uncorrelated or not correlated in successive observations. That is, like formula below, and you can see the graphic on the slide. Estimation, the method of least squares. Estimation of a simple linear regression relationship involves finding estimate of predict value of the intercept and slope of the linear regression line. The estimate regression equation is y equal b0 plus b1x plus e, where b0 estimates the intercept of the population regression line, beta 0. b1 estimates the slope of the population regression line, beta 1, and e stands for the observed errors, the residuals from the fitting estimate regression line, b0 plus b1x, to a set of endpoints. The estimate regression line is y hat equal b0 plus b1x, where y hat is the value of y lying on the fit regression line for a given. Error in regression. An error term is a residual variable produced by a statistical or mathematical model, which is created when the model doesn't fully represent the actual relationship between the independent variables and the dependent variables, as the graphic you can see below. Least square regression. The sum of square errors in regression is SSE equal sum of e squares equal sum of y minus y hat in parentheses squares. The least square regression line is that which minimizes the SSE with respect to the estimate b0 and b1. The normal equations are sum of y equal m b0 plus b1 times sum of x, then sum of x times y equal b0 times sum of x plus b1 times sum of x squared. sums of squares, cross products, and least squares estimators. Sums of squares and cross products are SSX equal sum of log up x minus x bar and then square equal sum of x squared minus sum of x. If you finish the sum, then use squares per n. SSY similar to SSX. SSXY equal sum of log up x minus x bar times y minus y bar equal sum of x times y minus sum of x times sum of y per n. Least squares regression estimators are B1 equal SXXY per SSX, B0 equal y bar minus D1 times x bar. Error variance and the standard errors of regression estimators. Degrees of freedom in regression, df equal log up n minus 2, where n is total observation less 1 degree of freedom for each parameter estimate, B0 and B1. SSE equal sum of y minus y hat squares equal SSY minus log up SSX times y squares per SSX equal SSY dikurang B0 times SSX times y. And unbiased estimator of S squared denoted by S squared, where NSA equal SSA per n minus 2. Square and sum our regression error to find SSE. Can you see the example in slide? Formula of standard errors of estimate in regression, as you can see below, the standard error of B0 intercept and the standard error of B1 slope. And you can see the example in slide.
Assalamualaikum warahmatullahi wabarakatuh. For the next slide, it will explain by myself. So let me introduce myself. My name is Felia Yuniva. My student number is 18109330 and 25. So let's go to the next slide.
Okay, we continue to the next slide. It talks about the correlation. The correlation between two random variables x and y is a measure of the degree of linear association between the two variables. The population correlation denoted by rho can take on any value from -1 to +1. If rho equal to -1, it indicates a perfect negative linear relationship. If rho is between -1 and +1, it indicates a negative linear relationship. If rho equal to 0, it indicates no linear relationship. If rho is between 0 and +1, it indicates a positive linear relationship. If rho is equal to +1, it indicates a perfect positive linear relationship. The absolute value of rho indicates the strength or exactness of the relationship. This is the illustration of the correlation. It consists of 6 illustrations. Next is the covariance and correlation. The covariance of two random variables x and y, where mu x and mu y are the population means of x and y respectively. Next is hypothesis test for the correlation coefficient. Here we have to testing the correlation coefficient with an with a hypothesis. It consists of null hypothesis and alternative hypothesis, where the null hypothesis rho is equal to 0 and the alternative hypothesis rho is not equal to 0. So this is the formula of the test statistic for the correlation coefficient, and this is the example calculation. So the conclusion is we rejected the H0 at 1% level. Next is hypothesis test about the regression relationship. This is the illustration. If y is constant, if unsystematic variation, if nonlinear relationship. Hypothesis test for the existence of a linear relationship between x and y. If the null hypothesis B1 equal to 0 and the alternative hypothesis B1 is not equal to 0. This is the formula to know the existence of a linear relationship between x and y, the test statistic, where B1 is the least square estimate of the regression slope and the SB1 is the standard error of B1. When the null hypothesis is true, the statistic has a t-distribution with the n minus 2 degree of freedom. Next is the hypothesis test for the regression slope. This is the example calculation. So here is the conclusion. We rejected H0 at the 1% level and we may conclude that there is a relationship between charge and mass travel from the example 10.1 and this for the example 10.4 in the previous slide. This is how we know that the regression is good or not. The coefficient of determination R square is a descriptive measure of the strength of the regression relationship, a measure of how well the regression line fits the data. The total deviation include unexplained deviation plus explained deviation. So the R square formula is 1 minus the standard error and the sum of standard t. Next is how to analyze ovariance and an F-test of the regression model. In this case, we analyze the regression model with using an F-test. This is the table. We need to search our regression error and we total of it. And this is the table of example 10.1, the calculation. So we get the F ratio, this, and the p-value is 0. So this is how to analyze, and we will analyze the F ratio with the F table that we get from the F table. If we use the degree of freedom n minus 2. Okay, that's all about the hypothesis and the correlation and the analysis of the regression model.
Assalamualaikum warahmatullahi wabarakatuh. The next slide will be presented by me. My name is Nabila Rifqha R. My student number is 181093 and 2008. So let's just go to the next slide. Now we will discuss about the normal probability plot of the residuals, and we will discuss about the graphs. First, this is the graphs for the probability that is flatter than normal. And then this is the graph for the probability that is more peak than normal. And then this is the graph for the probability that is more positively skewed than normal. And then this is the graph for the probability that is more negatively skewed than normal. And then we will discuss about the use of the regression model for prediction. First, point prediction. Point prediction is a single value estimate of y for a given value of x obtained by inserting the value of x in the estimated regression equation. And then there is prediction interval. There are two kinds of prediction interval. The first is for a value of y given a value of x. There is variation in regression line estimate and variation of points around regression line. And then the second is for an average value of y given a value of x. There is variation in regression line estimate. And then we will discuss about the errors in predicting EYX. We can see the graph for our certainty about the slope of the regression line. And then we can see the graph for our certainty about the intercept of the regression line. And then we will discuss about the prediction interval for EYX. This is the graph for the prediction interval for EYX. The prediction band for EYX is narrowest at the mean value of x. The prediction band widens as the distance from the mean of x increases. Predictions become very unreliable when we extrapolate beyond the range of the sample itself. And then this is the graph for additional error in predicting individual value of y. This is the graph for variation around the regression line, and then the graph for prediction interval for EYX. And then we will discuss about the prediction interval for a value of y. 1 minus alpha 100% prediction interval for y is y plus minus t alpha per 2 point s in the root of 1 plus 1 per n plus x minus x bar quadrat per s xx. For the example, the x is 4,000, and then we insert the number and we will get the result is 46,1943.559.7267. That's all from our presentation. Thank you for watching. Sorry if we had some mistakes. Assalamualaikum warahmatullahi wabarakatuh.